Now that we had a first look at the important data types and how we use them with the very important concept of variables, let's have a brief look at what exactly can be done with numbers or some important information you should have on them. So we got integers and floats, that's no news to you. Here are examples for integers, and the important part here is an integer in Python can be as big or small if it's a negative number as supported by your memory and operating system. Because 64-bit systems, for example, can leverage more of the memory than 32-bit systems. That's why the operating system also matters. But the important part is, this is the only limiting factor. There is no built-in cap or limit. So if you want to store a really big number in a variable, you can probably do that if your memory supports it. Now, another important piece of information, sometimes you have some data in a different data type. Let's say you have a valid number which for some reason is stored in a string, so text. Let's say you have the text 10. You recognize that it's text because of these rounding quotation marks, but you'd like to do a calculation with it. Now let me show you how this would work. Here's an example. Let's say I have my age, which is 29, but notice the surrounding quotation marks. If I now output age plus 1 here, you see I get an error that this must be a string, not an integer, because age is a string, but 1 is an integer. So what would work is age plus 1, and now we would have 291, because it's now not doing the arithmetic addition, where it adds 1 to 29, it's just concatenating the two strings and creating one word out of the two. Now, this is of course fine if you had something like hello plus world, and you wanted to create one combined string. But it's not what you want if you're working with numbers. And to fix this, or to have a solution for this case too, there is a helpful function, int. If you wrap a string or a float with that function, it actually converts it to an integer, which you can of course then use as a normal integer, because it is a normal integer. So back to the example here, we could say int age, and this would convert the age string, which is 29, to an integer plus 1. And now we don't get an error anymore, so this error from above is gone, but now we get 30 as a result. Now, as a side note, if you wrap something which can't be converted, you get an error. If you wrap a float, you get the, well, rounded integer, to be precise. As you can see with 1.8, it always rounds down, so it basically creates the floor of it. It cuts off the decimal place. And if you wrap true, for example, it gives you 1, and int false would be 0. That's also an interesting convention to keep in mind. True converted to an integer is 1, false is 0. And of course, we can also do these conversions with negative numbers, as you can see. There, it also just cuts the decimal place. So this is the int function. For floats, we also got some examples here. It's also important to know that your memory and operating system is the limiting factor when it comes to the size, or the biggest number or the smallest number you can store. And just as with int, you got the float function to convert other types to float. Here's another example. Let's say age is 29 as a string again. Now we can also output float age, and we get 29.0 because it's converted to a float, so to a number, and as a special number, a float. Therefore, float age plus 1 would give us 30.0. If we set float true, or if we write this, we get 1.0, and float false is, what would you guess? It's 0.0. So it's basically the same result as with the int function, but always attaching a decimal place. So just as the int function, this is very useful if you got some data in the wrong data type, but with a value which you know that it can be treated as a number, and then you got an easy way of converting that data type to a number. Now, one final piece of important information I want to share with you. Both integers and floats can also be written like this here at the bottom. You can add underscores to make long numbers easier to read. So let's say if I would store the amount of fans I got, which certainly is 1 million, then I can of course do it like this. This is a bit hard to read though, so what I can do is I can also write it like this. If I output fans, I still get the other format because that's the number with which Python will calculate. But when assigning the value, this clearly is easier to read. If I output fans plus 1, I still get the more unreadable output though, because again, internally, there only is one type of number. This underscore syntax is only there for improved readability.